Integration by parts. In the previous sessions, we learned how to integrate using different methods. It can be by substitution or it can be by trigonometric methods also. Now, how can we integrate using the method of by parts? So, before learning integration by parts, let's learn about how we can differentiate a product of two functions. Suppose I am asked to differentiate, that is d by dx of x sine x. So to differentiate x sine x, what should I use? I should use a product rule. So when I use the product rule, I will be directly getting that is differential of x sine x will be x into derivative of sine x, that is cos x, plus sine x into what is the derivative of x? It is 1. So it can be directly written as x cos x plus sine x, right? So that is simple. Differentiation of two functions which are in the form of a product is very simple. Use the product rule, that is u v dash plus v u dash. Now if I am asked to integrate x sine x dx, that is here I am asked to integrate a product of two functions. Is it that simple as differentiation? Can we write it as x into integral of sine x plus sine x into integral of x dx? Is it okay if I write it in that form? No, definitely we are not going to get the correct answer if I do it in this form. That is, this is not integration by parts, or this is not how we integrate a product of two functions. So that is where by parts comes into play. That is how we can integrate a product of two functions. So suppose you have two functions, integral, first function and second function, which is in the form of a product. To integrate this particular product, what you have to do is you have to identify which is the first function and which is the second function, which I will tell you later in the session. Suppose I'm taking this as the first one, f for the first one and s for the second function. Now, if I have it in this form, how to integrate? That is first function into integral of second function. So I'm writing it as what? Integral of second function minus what you have to write? Integral of the differential of first function, that is take the derivative of the first function into what you have written here, that is integral of the second function. So how to integrate the product of two functions? First function into integral of second function minus the integral of derivative of the first function into integral of second function. And you can write that in short as FIS, that is first into integral of second minus integral I, derivative of first d, first function f, then integral of second function. So I can also write it in short as what? FIS minus IDFIS. What is this FIS minus IDFIS? First into integral of second minus integral of derivative of first function into the integral of second function, and this is nothing but integration by parts. That is, you have a product, you split that into two parts, and then you integrate. And the formula goes like this: first function into integral of second function minus the whole integral of derivative of first function into integral of the second function. And now, how to choose this first function and second function? I told you earlier, we cannot simply take, okay, this is the first and this is the second. There is a particular rule that we have to follow when you choose the first function and the second function. And what is that? The rule goes like this. There's nothing but in the form of ILATE. And what is this ILATE? ILATE stands for, I stands for the inverse, L stands for log, A stands for algebraic, T stands for trigonometric, and E stands for exponential. So you have 5 different functions of the form of inverse, log, algebraic, trigonometric, and you have the last one, which is exponential. So what is this rule useful for? This rule actually tells you in what order you have to choose the two functions as the first or the second. That is, in which preference we have to give. So if I take the previous one, that is integral x sine x dx. So here it is a product of x and sine x. X is what? An algebraic function. Yes. Sine x is what? A trigonometric function. So according to the rule or ILATE that we follow, which comes first, algebraic or trigonometric? In ILATE, algebraic comes first. So what should be taken as the first function here? X should be taken as the first function. So this is the first function and this is the second function. Understood? So that this is the rule that we have to follow in cases where you have to choose between the first function and the second function, that is ILATE. In certain cases, we use the rule LEATE also, that is, in some cases, we take the logarithm as the first function also. Okay, we'll look at those questions later on. So for the time being, let's stick on to ILATE, where we take inverse, logarithmic, algebraic, trigonometric, and exponential in that order. Now, if I try to integrate x sine x dx, which is the first function x because it is algebraic, which is the second function sine x, trigonometric, in the rule it comes as the second one. So, x sine x, first and second. How to integrate first function into, that is x into, what is the second thing that you have to write? Integral of second. So, integral of sine x minus the whole integral of, what is the derivative? What is the next thing that you have to write? Derivative of the first function, that is d by dx of x into integral of the second function, that is integral sine x dx. So here also I am putting that dx. So you have x into integral sine dx minus integral of derivative of the first function x into integral of sine x dx. Now what is the integral of sine x? It is minus cos x. So you can write it as minus x cos x minus integral of, what is the derivative of x1 into, what is the integral of sine dx? Minus cos x dx. Minus cos x. Now there is a dx which is there for the whole integral, so minus cos x dx. Now there is a minus outside and minus inside, so I can cancel this and write it as plus. So what is the integral of cos x? It is nothing but sine x. So finally you can write as minus x cos x plus sine x plus c. So this gives us the answer of integral x sine x, which I have done using what rule? By the parts method. That is, by using ILATE, I found out which is the first function and which is the second function. And then I applied the method and I got the final integral of this question. Now, in the same way, I can do another questions which are of the form integral log x. So if I am asked to find out what is integral log x, I can find out this log x using the method that we just studied. What is log x? A single function. There is no product, right? But I can write log x in the form of a product as integral 1 into log x. Yes. Now, here 1 is what? An algebraic one, and log x is in logarithmic form. So, according to the ILATE rule, log comes before the algebraic one, right? Yes. So, log should be taken as the first function and 1 should be taken as the second function. Understood? Now, if I apply the by parts method, first function log x into, what is the integral? What is the next thing? Integral of 1 dx minus integral of, what is the derivative of log x? 1 by x into, the next thing is this integral 1 dx here. Now, log x into, what is the integral of 1 dx? It is x. So, log x into x minus integral of 1 by x into, what is the integral of 1 dx? X. This gets cancelled and you have only 1 dx left over there, and finally you can write as x log x minus x plus c. So this gives us the integral of log x also. So I have now found out what is integral log x, which was not known to me or you earlier. So this integral I have found out using the method of what? By parts. Same way I can find out integral sine inverse x dx also. That can also be found out using that method, right? How can I find out integral sine inverse x dx? Put integral sine inverse x dx as what? 1 into sine inverse x dx. According to the ILATE rule, inverse comes at the beginning, right? So you have sine inverse. So that should be the first function, and 1, which is an algebraic function, should be the second one. So first function is sine inverse x. Now how can I integrate? That is first function into, what is the integral of 1 dx x minus the whole integral of, what is the derivative of sine inverse x? 1 by root of 1 minus x square, and then you have this integral that we got here. So put that over here, you get it as x dx. So that is what you get. Now to integrate this part over here, put root of 1 minus x square, or inside 1, that 1 minus x square as t. So you have minus 2x dx is equal to dt, or x dx is equal to minus dt by 2. So this x dx, I'm writing it as minus dt by 2. So x sine inverse x minus, this one is minus dt by 2. So this becomes plus dt by 2. I'm putting it outside. And this denominator, root of 1 minus x square is now root t. Now x sine inverse x plus half of, what is the integral of 1 by root t? 2 root t. So 2 root t plus c. Put that t back as what? 1 minus x square. And you finally get it as x sine inverse x, half and 2 gets cancelled, plus root of 1 minus x square plus c, which gives us the integral of what? Sine inverse x also. So I have got integral of log x using the by parts method, integral of sine inverse x also using this by parts method. You can find out any integral of inverse functions using this by parts method. Understood? Now, if I'm asked to find out what is the integral of e raised to x sin x dx, can I use by parts method here? Yes, I can definitely use by parts method because it is a product of two functions. One is exponential and the other one is trigonometry. So I can use by parts over here. Now, when I use by parts, I'm going to face a challenge. And what is the challenge? Let's look at that. So if I take e raised to x sin x, and according to the Eilert rule that we follow, exponential comes at the last. So you can take this as the second function now itself, and this is the first function. So how can you integrate it? So first function, that is sin x into, what is the integral of e raised to x? E raised to x minus integral of, what is the derivative of sin x? Cos x into, again, what is the integral of e raised to x? That is e raised to x itself. So now when I took the by parts method over here, I'm not getting the answer directly over here. I've got another integral which is of the form e raised to x into cos x. Now let's do this one, this part. So the first part is e raised to x sin x minus the whole, I'm putting a bracket over here, the whole integral e raised to x cos x. What is this integral of e raised to x cos x? Again by parts. Again, this is the second function and this is the first function. So that is cos x into e raised to x minus integral of, what is the derivative of cos x? Minus sin x. So put that minus outside as plus. So plus sin x into, there is an e raised to x which has the integral e raised to x itself dx. So again, I'm not getting the answer. So two times I have done by parts over here. That is, first time when I did, I got another integral which is in the form of a product. I again did by parts over here. And again, I'm not getting the final conclusion over here. So what is the challenge that we have here? You have the same function which I took in the beginning, which came over here again, right? Is e raised to x sin x repeating? Yes. After two times I did by parts, it is repeating again and again. So in these cases, the question should be given in the form of what? I. So e raised to x sin x, because it is repeating, or whenever you are doing successive by parts over here, you are getting the same function which I had at the beginning. So if I keep on doing this by parts, I'm not going to end this by parts method and I'm not going to get the final integral also. So in these cases, you have to put the given question as equal to I. So when you put that is equal to I is equal to e raised to x sin x, the first step, that is e raised to x sin x minus integral of e raised to x cos x. And then I do it again, I get e raised to x sin x minus e raised to x cos x plus integral of e raised to x sin x dx. Now since I got it again, this one, can I term this as I? Yes, I can put this whole thing as I again. So what happens is, I is equal to e raised to x sin x minus e raised to x cos x minus, this one is completely the first function, that is I. And when I take it to the left side, that is minus I comes here, 2i is equal to e raised to x sin x minus e raised to x cos x, or I is equal to 1 by 2 e raised to x common and write it as sin x minus cos x plus c. So this gives us the integral of e raised to x sin x. So we had a challenge over here in by parts, that even when we do the number of times, if I take the by parts method over here, I am not going to get a final conclusion. So what I did over here, I put the initial integral as I, and I got the same thing again back here after two steps. So it was easy for me to find the integral of that particular question. Understood? Now there are certain properties, or there are certain standard integrals that we need to learn from by parts, and some of them are e raised to x into integral e raised to x into f of x plus f dash x dx. That is nothing but e raised to x fx plus c. Very important. The second one is integral root of a square plus x square. What is the integral of root of a square plus x square? It is nothing but x by 2 root of a square plus x square plus a square by 2 log mod x plus root of x square plus a square plus c. So that is integral root of a square plus x square. And now we have over here integral root of x square minus a square dx. What is the integral of x square root of x square minus a square dx? It is nothing but x by 2 root of a square minus x square, or x by 2 root of x square minus a square plus a square by 2 log mod x plus root of x square minus a square plus c. And the last one is integral root of a square minus x square dx, which is nothing but x by 2 root of a square minus x square plus a square by 2 sine inverse x by a plus c. So these are the different standard integrals that we have to learn in this session that has been by part. So you have to remember this so that we can do more problems in these when the integrals are of this particular form. That is 4 different forms we have learned over here. So that is about integration by parts. Now we have learned different methods of finding integrals by substitution, then by trigonometric identities, and now by parts. Now we have to move on to another part of integration where we have boundaries. When there are boundaries, what happens to the value of the integral? Does it remain the same or does it change? More about that you will learn in the upcoming videos. For the time being, let's have a quick recap of what we have learned in this session.
Manorama Horizon. Learning made simple.